For this part, we need to write equivalent forms of quadratic equations. So what I'm going to do here is use our area model to distribute. So here, for our length, we have 2x and 1. And then for our width, we have x and -2. So 2x times x is 2x squared. And 2x times -4 is minus 4x. 1 times x here is 1x, and 1 times -2 is -2. So here we have 2x squared, and then minus 3x and minus 2. Here we have x minus 4 squared plus 1. So what I'm going to do is expand just the x minus 4 times x minus 4 here. So that's x squared minus 4x minus another 4x plus 16. So this ends up being x squared, -4x minus 4 more x is minus 8x, then plus 16. But we still have our plus 1. So for g of x, this equals x squared minus 8x plus 17. Here, this is f of x. Now here, we're going to factor these. So I'm going to use my area model. And this is x squared and minus 18. So we have x and x. And we need factors of -18 that add together to be -3. So I'm thinking, well, we could have -18 and 1. That's not going to work. -9 and 2, but -9 plus 2 is -7. So how about -6 and 3? So if I did -6 and 3, -6 times 3 is -6x. 3 times x is 3x. And then adding that, you get x squared minus 3x, and then minus, I'm sorry, that's on the inside. So, yep, that does add up. But here in factored form, h of x here is equal to x squared. The x plus 3 here. So writing the factored form. And x minus 6 here. So now here, to factor 2x squared plus 11x plus 12. Make this a little bit bigger. So we have 2x squared. Remember, to make 2x squared, we're going to have 2x and 1x. Then this is going to have to be 12. So I'm going to write these small because we need factors of 12 that sum together to make 11. So as I'm thinking about that, I could have 6 and 2. But if I put 6 here, 6 times 2 is 12x, and that's already too big. If I put 6 here, that would be 6 times 1. And then 2 here, 6 plus that 2 would make 8. So it can't be 6 and 2. So I'm going to go back to and think about, well, what about if I put 3 and 4 here? So if I put 4 here, and that's x, and this is 3, 4 times 2 is 8x. 3 times x is 3x. 8x plus 3x is my 11x. And this would be k of x equals x plus 4 times 2x plus 3. And then putting this here in vertex form, we would have to complete the square. So what I'm going to do is show you how to complete the square and then use that in vertex form to leave that unchanged. So here we would have x squared, and we're going to make this -2 part go away for a second. So if I'm thinking about 8x and I had 8x to split into two parts, this would have to be 4x and 4x. So the question is, what would I add here to make that work? So this would be x, and this would be 4 and 4. This part would be 16. So what I'm going to do is go m of x equals x squared plus 8x. Now I'm going to add the 16. However, because I added 16, to make that not unbalanced, I'm going to have to subtract 16 and then subtract 2. Now what I'm going to do is take this part, and this is a perfect square that goes and factors into x plus 4 squared. So I'm going to write m of x equals, in parentheses, x plus 4 squared. And then here, negative 16 minus 2 is negative 18. Now my vertex, remember, it's x minus h, so this would be the opposite of 4, which is negative 4. And then this is the k value, or the y value, which is negative 18. So, of course, we're going to practice that again. So if I do this, and I have to complete the square on a polynomial with an a term. So in order to do this one, what I need to do is factor 2 out of the expression. So this is going to become 2 times x squared minus 6x minus 1/2. So then from here, to make this a perfect square, we're going to think about having x squared, and then I take my negative 6x and I split it up into negative 3x and negative 3x. So this would be x minus 3 and x minus 3. And then this would become positive 9. So what I need to do is take this piece, the 9, and add 9, and then also subtract 9. So this becomes 2 times x squared minus 6x minus 9, but now plus 9, but now I also subtract 9 and then subtract 1/2. This part becomes a perfect square. So we have 2 times, and then this becomes still, and I'm going to leave a parenthesis here, 2, x minus 3 squared. And then here I'm going to write this as minus 9.5. Now, what's going to happen is if I want to take this portion of the minus 9.5 out of parentheses, I'm going to multiply or distribute just that part. So here, this is going to become 2, and then times x minus 3 squared, but 2 times negative 9.5. So 2 times negative 9.5 becomes negative 19. So this is n of x equals, and this is quite a challenging one. So if you had difficulties with it, it is quite challenging. And then to just verify those are the same, I can put in 2x squared minus 12x minus 1, and 2 times x minus 3 squared minus 19, and then graph those, and they overlay and become the same equation.